Alright, so for all you complainers about the audio quality of these videos, I'm making a new video here for rotations, so hopefully you can hear me. I should have fixed all the technical problems. Sorry about the mix-up on the other videos, but this one should be good. You should be able to hear me, hopefully. Okay, so rotations. Rotations, this is where we are going to be talking about, if you think about rotations, you think about things that rotate. The other word that we would use for rotations would be to turn. Okay, so we are going to be turning our shapes around our coordinate plane and stuff like that. So an example, just do a quick one. So get ourselves a coordinate plane here. So let's say I have my first shape here. We'll do a triangle. We'll call this A. Okay. So if we think about a coordinate plane, we've got these four quadrants, right? And if we draw a circle connecting them all, we'd have our four quadrants. Now a circle has 360 degrees, right? If we think about these quadrants, they are all 90 degrees. Okay, so if we rotate something 90 degrees, it's going to move to the next quadrant. If we're going clockwise, it would go this direction. If we're going counterclockwise, it's going to go this direction. And if we go 180 degrees, that means it's going to move two quadrants, which means it would end up over here in this quadrant. So let me do an example of when you rotate 180 degrees. So rotate 180 degrees. Now, if I rotate clockwise, is that going to be any different than rotating counterclockwise? No. Either direction, you're going to end up in the same spot. Now, if you think about turning something, it does kind of alter the shape a little bit. So if I were to rotate this triangle 180 degrees, it's going to look a little bit different when I rotate it. So it would kind of go like upright when you go this way, and then it kind of go upside down, and then upright again, and then it would match its shape if I went all the way around. So if it was going 180 degrees, it's going to end up slightly upside down, so it's going to look something like this. I mean, that is not to scale at all. This is just a quick demonstration where this would be like the A prime, the new point there after I rotate it. Okay. So when we talk about this, there are some tricks. We can actually turn our paper and stuff and see what it would look like if we rotated 180 degrees. See, I rotated this paper 180 degrees and it's upside down. It's kind of like the triangle I just drew. Okay, so there are some tricks to it that we can use, but there are some rules that go with it as well. Okay, so for example, since I just did the 180 degrees, if you rotate 180 degrees, what happens to your ordered pair is the X and Y X and Y, do the and symbol here, X and Y signs change. So everything stays in the same spot, just the X and Y change. So if you had an ordered pair with some generic X and Y, the new ordered pair after you rotate 180 degrees would be a negative of the same number for X and a negative of the same number for Y. Okay, so that's what happens when you rotate 180 degrees. Now, it gets a little bit trickier with the 90-degree rotations. We're only going to worry about 90 degrees and 180 degrees for our rotations. But let's do our two 90-degree rotations. There's two directions we can go 90 degrees. We can go clockwise, which would be going to the right. We can go counterclockwise, which would be going to the left. So let's do 90 degrees clockwise first, which is going to the right. Okay. What happens to our ordered pair here is the X and Y switch, and the new Y coordinate changes signs, and new Y changes signs. So for example, if you have your generic x and y, it would become, the y would go where the x was, and then the new y coordinate would be the previous x coordinate, and they would change signs. Okay? So the new y changes signs. Now, an example of an ordered pair here. So let's say I have 2, 5. Okay, what happens is the 5 would become the new x coordinate, and then the 2 would become the y coordinate, but it would change signs. It would become -2. Okay? And if you think about that on the graph, it was 2, 5, so it was up here. If it's 5, -2, it's now down here in this quadrant. So again, it went one quadrant over. Okay, then let's talk about the other 90-degree possibility. So the 90 degrees counterclockwise which would be going to the left. Okay, so that's going to the left. You're going against the way the clock ticks. Okay, again, the x and y switch. And the new x changes signs. Okay, so again, just generically, we got our x and y. If we were to rotate counterclockwise 90 degrees, they would switch places, and the y, the old y coordinate would become your x, the new one, or the x would become the y, and this new x coordinate would change signs. Okay, so an example of an ordered pair. So let's do 3 and 7. So that 7 would become the x, and the 3 would become the y, and the 7 would change signs. So it would become -7. So again, if you think about it, 3 7s in this quadrant. If we did -7 3, it would be -7 3. It's in this quadrant now. Okay, so it went to the left one quadrant. Okay, and those are your rules. Those are going to be very important to know when you are dealing with ordered pairs and stuff like that. So these are important notes that you can use on the test and quiz. Okay, so make sure you are taking them and writing good notes. Okay, let's look at some examples. So let's start by rotating this shape 180 degrees. And I've got a lot of papers on my desk that are in the way. So let's kind of zoom in here so you can see. So like I said, this wants me to rotate this triangle 180 degrees. Now, there are a couple ways we can do it. We can look at our ordered pairs right now and then do the rule. So all we'd be doing is changing the signs, right? They stay in the same spot, they just change the signs because it's 180 degrees. Another way we could do it is we can literally rotate our paper 180 degrees. Okay? So we've just rotated our paper 180 degrees. That's what my shape should look like after I've rotated 180 degrees. So if I treat this as the, this is a positive y, this is positive x now, and figure out the ordered pairs of where they are right now, that would give me my new ordered pairs. So let's try it and see. So the new ordered pairs, so this is Q, right? So I'm going to write these upside down. No, I'll write them where they should be. No, I'll write them upside down so you can kind of see. So Q prime is going to be at 0 and negative or positive 1. So 0, 1. Okay. Then J prime is over here at 5 and 3. And then H prime is going to be over here at 3 and 5. So H prime, 3, and 5. Okay, let's rotate back. So let's just hurry and graph those. So Q was at 0, 1. So this is Q prime. Remember to label everything when you graph it. Okay, Q prime. J prime was 5, 3, so 5, 3, J prime. And then H is 3, 5. 3, 5. H prime. There's the new rotated shape. Now let's compare, let's see if the rule works. So remember, the rule with 180 degree rotation was that they changed signs. They stayed the same, but they changed signs. Okay, so if we look at it, this is at 0, negative 1. So Q was originally 0, negative 1. H was at negative 3 and negative 5. And then J was at negative 5 and negative 3. Okay, so if we look at that compared to our prime stuff, they're the same order pair, right? We just changed the signs. And I got those just from rotating my paper 180 degrees. So, I know I'm pretty awesome, but what can you do? All right, then let's look at an example of a 90 degrees counterclockwise. So let's do it counterclockwise. So again, I could do these just from turning my paper, or I could use my rule, whatever's easiest for you. I'll do another one where I turn my paper. So if I were to turn my paper counterclockwise, remember this would need to end up in the left quadrant because it's going counterclockwise. So, and again, you just turn your paper 90 degrees to the left and it should end up there. Hey, look, there it is. It's in the upper left quadrant now. So again, if I just wrote down what the ordered pair is now, that would be the proper ordered pair for when I rotate it. So let's look at these. Let's do R first. This is at negative 5 and positive 4. So R prime is going to be negative 5 and positive 4. S is going to be negative 2, positive 2. So S prime, negative 2, positive 2. And then L, and Franklin Oakham's to the main office. All right. And then 0 and 5 would be my L prime. So 0, 5. Okay. So let me just turn it back and let's try graphing it, see if it's right. So I've got negative 5, 4 would be R prime. So negative 5, 4 is up here. There's R prime. Then I've got negative 2 and 2. So negative 2, 2. There's my S prime. And then I've got 0 and 5 for L. There's L prime. So there is my triangle rotated 90 degrees counterclockwise. So let's compare these order pairs to the original and see if our rule holds up. So R is originally at 4 and 5. So original R is 4 and 5. And then S is originally at 2 and 2. So 2 and 2. And then our L is at 5 and 0. So L is at 5 and 0. So if we compare these, let's look at the top one. So we swapped quadrants or coordinates, and then the new X became negative, right? Does that match my rule? We're counterclockwise. The new X changes signs. Yes, it does. Okay, so that's how it works. Now, what if you don't have the graph that we can just rotate? Then we have to actually use our rule. So let's do one where I haven't done one yet. So let's do the clockwise one. So clockwise, they switch, and then the new Y changes signs. So let's do this one. So S prime, they're going to switch spots. So negative 4 is going to go where the X is. And then 1 is going to go where the Y is. But again, the new Y changes signs. So it'll be negative 4, negative 1. Okay? Then W, Again, they switch spots, so 0 would go where the x would go, and then y would go where the y is. But again, the new y changes sign, so it'd be -1. And then j, we would have j prime. -4 would go where the x is, and then 3 would go where the y is, but it would change signs, so it'd be -3. Okay? And that would be your transformed points there. Last thing we need to talk about is when we talk about the rules. So again, when you're looking at the rules...
If you have any students riding the late bus, please be sure to give them a bus ticket and put their name on the late bus.
Yeah.
Thank you very much.
Perfect timing to do a video, right? Okay. So when we're looking at these shapes, again, we look for the shape that does not have the apostrophe or the prime symbol. That's our original. And then the new shape would be our transform shape. So we're dealing with rotations here. So if we rotated one quadrant to the right, that's going clockwise. How many degrees? 90 degrees. So to describe the rule to describe this, we would just write 90-degree clockwise. Okay? And that's all I want you guys to do on this one, is just basically write what it's doing. Okay? Double check with your teacher. They might want you to actually do the rule. So they might want you to do x, y, going to the new clockwise would be y -x. They might want you to write something like that. Okay? I just want you to identify what transformation it is. This one is going 2 quadrants over, so this would be 180-degree rotation. That's all you need to do. Okay? And that's that. Sorry for the long video.